All right. Hi to Brennan and Eating and Tom, who are not here. We miss you. We hope you're having a good Friday, and we'll see you guys back here on Monday. We're going to finish up Chapter 9 today. We're going to talk about what happens when the bounds of an integral are fine, but something within the bounds is an undefined value. So yesterday it was something was wrong with the bounds itself, and now it's going to be something wrong with something within the bound. All right, so let's talk about, I just want to talk about properties before we jump into examples. Okay, if a value C is not defined within the domain A to B for f of x. All right, so for example, you have a beginning value and an ending value, but somewhere in that interval there's a C that's a problem for the domain. Okay, so let's see. Let's say you have a hyperbola that's 1 over x plus 5. What number is not part of the domain? -5, right? But what if your bounds are like -10 to 10? And so you have a value within there that's a problem. Then what do you do? So then the integral from a to b of f of x dx has to be broken up at that value c. And so it will be equal to, and we're going to go from, we already know we can do this, from a to c of f of x dx, and then from c to b of f of x dx. So we're breaking up the integral into two pieces. And then because c is the problem point, then we need limits as well. If c was a defined number within our integral, our interval, it would be fine. But when c is an undefined value, if it's not part of the domain, so then we have to do a substitution. So we're going to do the limit as u approaches c from the left. And so then we're going to go from a to u. And then we add to it the limit as u approaches c from the right, going from u to b. So we break up the integral at c, and then we replace the limit with the left and the right-hand side. And then we proceed as usual to evaluate the antiderivative and substitute, and then evaluate the limits. So that's the first property, is if the c is not defined within the domain. There's a couple corollaries to that, is if c is actually an endpoint, and then you just do one side or the other. Okay, so a corollary to that if we're going from C to A, in other words, C is not included, but A is. Okay, so your domain is one part that can you still do an integral, even though the domain doesn't include that value of C. Okay, and then that's true, yes, we can still go from C to A if we replace it with a limit. And so we need to make sure that our u is approaching what side of C. What side of C do we need to make sure we stay on if we can't include C? The right side, the positive side. So that'll be C plus, and u will go from u to A of f of x dx. Okay, so if C is the left-hand bound but not included, we need to stay on the right side of C. And then the corollary to that, is if it's the other way, if A is included, but C is not, as the ending bound, you're going to do the reverse. So then your integral that goes from A but ends at, trying to end at C, but it can't, would get replaced with the limit as u approaches C, and you stay on the left side this time, from A to U of f of x dx. So there's a lot of letters and a lot of numbers and a lot of limits and a lot of pluses and minuses, but it'll make, when we actually do the, I've got 3 problems prepared, so we'll see if we can get through those before the bell rings. But you want to make sure that you're staying on the correct side of that undefined value. Any questions on the basic idea of it? Does that make sense? Okay, let's try it. Okay. So let's try the integral from 0 to 1 of the function 1 over rad x dx. Okay, so the problem is with which bound? 0. 0 is not part of the domain, and so the interval that we're working on is a soft-sided 0 to 1. Okay, we can't include 0, so we have to make sure that we stay on the right side of 0. And so we're going to replace 0 with a u, and we're going to make sure that u stays on the right side of the value 0. And then we do our antiderivative. So the antiderivative of the 1 over the rad of u is the regular rad of u divided by half, or multiplied by 2, plus c, going from u to 1. And so then we're going to substitute. Whoops, it's an x. All right, and then we've got 2 times the square root of 1 minus 2 times the square root of u. And then we plug in u plus into that, so we have 2 minus 2 times the square root of u of 0 plus, which is just 2 minus 0, and so the value is 2, and we say that this integral converges to 2, even though the bound wasn't part of the original domain. Any questions about that one? Okay, let's try another one. All right, let's try the integral from 1 to 2 on 1 over x minus 2 dx. And this time it's the opposite. So which of the bounds is the problem? 2 is the problem because the interval is 1, but 2 is not included on the domain of the function. So we're going to do the reverse. And we'll find the limit as u approaches 2 from the right side. And so now our bounds will go 1 to u. And we're just going to make sure we stay on the right. So this will be the limit as u approaches 2 from the right of the natural log of the absolute value of x minus 2 plus c, going from my new bounds of 1 to u. I'm not sold on the letter u. I don't care. I mean, yes. Did I say it right and write it wrong? I don't remember what I did. If you use the letter A, or, you know, I'm not sold on that. It doesn't have to be the letter U. Okay, whatever you want to use. All right, so we're looking at the natural log of the absolute value of u minus 2 minus the natural log of the absolute value of 1 minus 2. So that will give us the natural log of 2 minus 2 minus the natural log of the absolute value of negative 1. So the natural log of 0 minus and minus the natural log of 1. Now what's the absolute value of 0 minus? 0 plus. So the natural log of 0 plus minus 0. And what is the natural log on the right side of 0? Can you think of the natural log function? And where is the natural log on the right side of 0? Yeah, it's way down at negative infinity. You can even just picture the graph of that. Okay, the right side of 0 is way down at negative infinity. And so we would say this diverges because we don't have a numerical value. Oh, we're in good shape. Okay, one more, even though we're on assembly schedule. Yes, ma'am.
I didn't know at all. Wait, did they ever announce it?
There's any announcements this morning. Did your first grade teacher read it? Does he read them? Okay, anyway. Okay, so how about 0 to 3 of 1 over x minus 1 to the 2/3 dx? All right, so the bounds are fine. 0 and 3 are both fine. What's the problem? 1. So our domain is going to be going from 0 up to 1, which is fine, and then from 1 to 3, when 3 is also fine, but we cannot use 1. So we're going to split this integral up, and I need to stay on the safe sides of 1. And so my first integral, I'll be making sure that we stay on the left side of 1. And we'll go from 0 to u of the function. And for my other one, I'll make sure I stay on the safe side of 1, which would be the right. And I'll be going from u to 3. And then we proceed with our antiderivatives for each of those. All right, the antiderivative of x minus 1 to the 2/3 is x minus 1 to the positive 1/3 times 3 plus c. That one going from u to 0, and then we have the same exact thing. All right, on the safe side of 1, which is the positive side, and we have 3 times x minus 1 to the 1/3 plus c, going from u to 3. And then we'll plug in our bounds, and then we'll evaluate our limits. So the safe side of 1 is negative 1 minus, and we're looking at 3 times the cubed root of u minus 1 minus 3 times the cube root of 0 minus 1 plus the secondary limit (3 times the cube root of 3 minus 1 minus 3 times the cube root of u minus 1. All right, so all together, we now have 3 times the cube root of 1 minus minus 1, which is 0 minus 3 times the cube root of negative 1, plus 3 times the cube root of 2, minus 3 times the cube root of 0 plus. And so those 0 minus and 0 pluses can be applied to the cube root, but they're both going to have the value of 0. And then the cube root of negative 1 is negative 1. So we end up with 3 plus 3 cube root 2. And so this converges because we get a defined answer. We get a definite value, which means the area is converging upon that value. It is not equal to the value. It is converging upon that value.